A vehicle tracking system combines the use of automatic vehicle location in individual vehicles with software that collects these fleet data for a comprehensive picture of vehicle locations. Modern vehicle tracking systems commonly use GPS or GLONASS technology for locating the vehicle, but other types of automatic vehicle location technology can also be used. Vehicle information can be viewed on electronic maps via the Internet or specialized software. Urban public transit authorities are an increasingly common user of vehicle tracking systems, particularly in large cities. Active versus passive tracking. Several types of vehicle tracking devices exist. Typically they are classified as passive and active. Passive devices store GPS location, speed, heading and sometimes a trigger event such as key on off, door open closed. Once the vehicle returns to a predetermined point, the device is removed and the data downloaded to a computer for evaluation. Passive systems include auto-download type that transfer data via wireless download. Active devices also collect the same information but usually transmit the data in near real-time via cellular or satellite networks to a computer or data center for evaluation. Many modern vehicle tracking devices combine both active and passive tracking abilities. When a cellular network is available and a tracking device is connected, it transmits data to a server. When a network is not available, the device stores data in internal memory and will transmit stored data to the server later when the network becomes available again. Historically, vehicle tracking has been accomplished by installing a box into the vehicle, either self-powered with a battery or wired into the vehicle's power system. For detailed vehicle locating and tracking, this is still the predominant method. However, many companies are increasingly interested in the emerging cell phone technologies that provide tracking of multiple entities, such as both a salesperson and their vehicle. These systems also offer tracking of calls, texts, web use and generally provide a wider range of options. Typical architecture. Major constituents of the GPS-based tracking are: GPS tracking device. The device fits into the vehicle and captures the GPS location information apart from other vehicle information at regular intervals to a central server. The other vehicle information can include fuel amount, engine temperature, altitude, reverse geocoding, door open close, tire pressure, cut off fuel, turn off ignition, turn on headlight, turn on tail light, battery status, GSM area code, cell code decoded, number of GPS satellites in view, glass open close, fuel amount, emergency button status, cumulative idling, computed odometer, engine RPM, throttle position, GPRS status and a lot more. Capability of these devices actually decide the final capability of the whole tracking system. GPS tracking server. The tracking server has three responsibilities: receiving data from the GPS tracking unit, securely storing it, and serving this information on demand to the user. User interface. The UI determines how one will be able to access information, view vehicle data, and elicit important details from it. Common uses. Vehicle tracking systems are commonly used by fleet operators for fleet management functions such as fleet tracking, routing, dispatching, onboard information and security. Along with commercial fleet operators, urban transit agencies use the technology for a number of purposes, including monitoring schedule adherence of buses in service, triggering changes of buses' destination sign displays at the end of the line, and triggering pre-recorded announcements for passengers. The American Public Transportation Association estimated that, at the beginning of 2009, around half of all transit buses in the United States were already using a GPS-based vehicle tracking system to trigger automated stop announcements. This can refer to external announcements at a bus stop, announcing the vehicle's route number and destination, primarily for the benefit of visually impaired customers, or to internal announcements identifying the next stop, as the bus approaches a stop, or both. Data collected as a transit vehicle follows its route is often continuously fed into a computer program which compares the vehicle's actual location and time with its schedule, and in turn produces a frequently updating display for the driver, telling him/her how early or late he/she is at any given time, potentially making it easier to adhere more closely to the published schedule. Such programs are also used to provide customers with real-time information as to the waiting time until arrival of the next bus or tram streetcar at a given stop, based on the nearest vehicle's actual progress at the time, rather than merely giving information as to the scheduled time of the next arrival. Transit systems providing this kind of information assign a unique number to each stop, and waiting passengers can obtain information by entering the stop number into an automated telephone system or an application on the transit system's website. Some transit agencies provide a virtual map on their website, with icons depicting the current locations of buses in service on each route, for customers' information, while others provide such information only to dispatchers or other employees. Other applications include monitoring driving behavior, such as an employer of an employee, or a parent with a teen driver. Vehicle tracking systems are also popular in consumer vehicles as a theft prevention, monitoring and retrieval device. Police can simply follow the signal emitted by the tracking system and locate the stolen vehicle. When used as a security system, a vehicle tracking system may serve as either an addition to or replacement for a traditional car alarm. Some vehicle tracking systems make it possible to control vehicle remotely, including block doors or engine in case of emergency. The existence of vehicle tracking device then can be used to reduce the insurance cost, because the loss risk of the vehicle drops significantly. Vehicle tracking systems are an integrated part of the layered approach to vehicle protection, recommended by the National Insurance Crime Bureau to prevent motor vehicle theft. This approach recommends 4 layers of security based on the risk factors pertaining to a specific vehicle. Vehicle tracking systems are one such layer, and are described by the NICB as a very effective in helping police recover stolen vehicles. Some vehicle tracking systems integrate several security systems, for example by sending an automatic alert to a phone or email if an alarm is triggered or the vehicle is moved without authorization, or when it leaves or enters a geofence. Other scenarios in which this technology is employed include stolen vehicle recovery. Both consumer and commercial vehicles can be outfitted with RF or GPS units to allow police to do tracking and recovery. In the case of LoJack, the police can activate the tracking unit in the vehicle directly and follow tracking signals. Fleet management. When managing a fleet of vehicles, knowing the real-time location of all drivers allows management to meet customer needs more efficiently. Whether it is delivery, service or other multi-vehicle enterprises, drivers now only need a mobile phone with telephony or internet connection to be inexpensively tracked by and dispatched efficiently. Asset tracking. Companies needing to track valuable assets for insurance or other monitoring purposes can now plot the real-time asset location on a map and closely monitor movement and operating status. Field service management. Companies with a field service workforce for services such as repair or maintenance, must be able to plan field work unregistered trademark time, schedule subsequent customer visits and be able to operate these departments efficiently. Vehicle tracking allows companies to quickly locate a field engineer and dispatch the closest one to meet a new customer request or provide site arrival information. Field sales. Mobile sales professionals can access real-time locations. For example, in unfamiliar areas, they can locate themselves as well as customers and prospects, get driving directions and add nearby last-minute appointments to itineraries. Benefits include increased productivity, reduced driving time and increased time spent with customers and prospects. Trailer tracking. Haulage and logistics companies often operate lorries with detachable load-carrying units. The part of the vehicle that drives the load is known as the cab and the load-carrying unit is known as the trailer. There are different types of trailer used for different applications, for example, flatbed, refrigerated, curtain-sider, box container. Surveillance. A tracker may be placed on a vehicle to follow the vehicle's movements. Transit tracking. This is the temporary tracking of assets or cargoes from one point to another. Users will ensure that the assets do not stop en route or do a U-turn in order to ensure the security of the assets. Fuel monitoring. This is another important usage of vehicle tracking to monitor the fuel through tracking device. Distance calculation. This is an important usage of vehicle tracking to calculate the distance traveled by the fleet. Vehicle tracking systems are widely used worldwide. Components come in various shapes and forms, but most utilize GPS technology and GSM services. While most will offer real-time tracking, others record real-time data and store it to be read, similar to data loggers. Systems like these track and record and allow reports after certain points have been solved. Unconventional uses. Industries not traditionally known to use vehicle tracking systems have started to use it in creative ways to improve their processes or businesses. The hospitality industry have caught on to this technology to improve customer service. For example, a luxury hotel in Singapore has installed vehicle tracking systems in their limousines to ensure they can welcome their VIPs when they reach the hotel. Vehicle tracking systems used in food delivery vans may alert if the temperature of the refrigerated compartment moves outside of the range of safe food storage temperatures. Car rental companies are also using it to monitor their rental fleets. See also, anti-hijack system, automatic number plate recognition, automatic vehicle location, fleet telematics, fleet tracking, GPS tracking server, GPS wildlife tracking, intelligent transportation system, InVanet, mobile phone tracking, privacy law, informational self-determination, privacy, data security, track and trace, tracking system, vehicle infrastructure integration. References